find the expected value, we need to list all of the situations that can occur that we're interested in, find the probability of each thing happening and the value of each thing happening, multiply those and add them all up. Here's a sample problem. So in this game, as you can see, we've got these situations. The person pays $2 to play. If they draw a face card, they're paid $4, so there's one thing that can happen. If they draw any other card, then they lose their $2. So there's two scenarios. They either draw a face card or they don't. And so let's look then at what we need to find. We need the probability that they draw a face card, the value of drawing a face card, the probability of not drawing a face card, and the value of not drawing a face card. So we've done these before, the probabilities anyway. The probability they'll draw a face card. There's 12 face cards. There's 52 cards, so the probability is 12 out of 52. Now, if this is 12 out of 52, then the rest of the cards would be 52 minus 12, or 40 out of 52. Now, how about the value? First, notice we're looking at this from the casino's perspective. So let's look. A player pays $2 to play. They draw a face card and they're given $4. So what does the casino see? They got $2 from the player. They gave them $4. So the casino has lost $2. In the other scenario, we're told here that if they draw any other card, they lose their $2. So they paid $2 to play. They do not get it back, meaning the casino is gaining the $2. And so now we want to multiply these together and add them up. You can go do that on your calculator. I've already done it, so I won't show all the mechanics of that. That comes out to be a positive $1.08. The casino looks at this like every person that plays the game, we're getting $1.08 from them. We've got our spinner that we've used before, and we want to know if we pay $1 to spin. If it lands on blue, we get our dollar back. Lands on yellow, the player is paid $2. Lands on green, they're paid $3. Otherwise, they don't get anything. And so, what is the expected value of a person who plays the game? So that's the perspective from the person. So what do we need? We need to list the things that can happen. And here's what we got. It can land on blue, yellow, green, or red. Those are the only things that can happen. We need to know the probability of each and the value of each. The probabilities we've already done before. Now the values. I'll explain the values like we did before. The person lays down their dollar. If it lands on blue, the person gets their dollar back. So what have they gained? 0. What about yellow? It says if the spinner lands on yellow, the player is given $2. Well, if they paid $1 and they're given $2, then they have gained $1. How about green? If the spinner lands on green, the player is given $3. They paid $1 to play. They're given $3, so they have gained $2. That's positive. And then the last one, otherwise, meaning if it lands on red, that's the only other thing there is, they lose their dollar. The value of landing on red is losing $1. That's -1. We simply multiply those together and add them up. And again, you do this on your calculator. And -8 cents. On the average, every time a player plays this game, they can expect to lose 8 cents. So in this one, again, we need to look at all the things that can happen. They're going to draw out a ticket, and that person will win $500. So one thing that can happen is you can win $500. Then there's some people, 3 to be precise, that's going to win $100. So another thing we can do is win $100. There's going to be several people that's going to win $20. There's going to be some people that wins $5. You probably can guess this. It's implied by the nature of what's going on. There's going to be a whole lot of people that don't win anything. They just lose their money. And so these are the things that can happen in this problem. We need to compute these one at a time. How about the probability of winning the $500? Well, there's one ticket that's going to win the $500. There's 5,000 tickets sold. What's the probability someone will win the $500? 1 out of 5,000. You want to be careful in assigning the value, because you see here the person paid $1 to play. You give them a check for $500, what have they gained? Well, $1 of it is what they paid, so they've only gained $499. Then we can go through a similar process for the others. What's the probability of winning the $100? Well, it says there are 3 winners for the $100. So you got a 3 out of 5,000 chance for winning the $100. And just like before, we say, well, we win 100, we paid $1, so we're only gaining $99. Similarly, for the $20, there's 5 tickets that win $20, so you got a 5 in 5,000 chance of winning the $20, and the value of winning the $20 is 20 minus 1, or $19. The probability of winning the $5, very similarly, it says there's 20 people that's going to win a $5 prize, so 20 out of 5,000 is the probability of winning the $5, and the value would just be the $4. We take out the dollar we paid to play. Now finally, what's the probability of not winning anything? Well, we can use a little trick here that we learned in an earlier section. If we add these first 4 together, that's 20 plus 5 is 25, 28, there's 29 winners out of 5,000 people. So how many does that make that are not winners? That would be 5,000 minus 29. So the probability of not winning is 4,971 out of 5,000. The value, of course, is you lose your dollar. And like before, we can take out our calculator, multiply these together, add them up, change that to a dollar amount, and we find out that the person on average expects to lose 80 cents. So your expectation in buying one of these lottery tickets is you're giving 80 cents to somebody. The final problem looks like this. This is a more realistic business type scenario. We've got a company that's thinking about drilling at 2 different sites. There's some costs involved, and there's some success involved, and there's probabilities involved. What we need to do is to compare each of these 2 and see which one has the higher expected value. That kind of drives the business's decision as to which one to choose. What we'll do is we'll compute the expected value for each site, and then compare the two. We would want to choose the one with the larger expected value. And so for site A, we need the probability of a success times the value of success. The only other thing, if it's not successful, then it's failure. So we need all the probabilities and all the values. Same thing for site B. And so look at site A. What is the probability of success? Well, that's given in the problem. Site A will net 30 million if successful. Site B will net 70 million if successful. There is a probability of 20% that site A is successful. So for site A, the probability of success is 20%. The value given in the problem of success is $30 million. Now, we know that if it's 20% probability of success, it must be an 80% probability of failure. The two have to add up to 100%. The value of failure is to lose the 3 million, as in the negative 3. And so multiplying these together and adding them up, we get 3.6. Very similar scenario for site B. Probability of success, value of success. For site B, we're told the probability of success is 10%. That means the probability of failure is 90%. So we take our probabilities, fill them in. The value of success is the 70 million and negative 4 million, the value of failure. Multiply them together, add them up. The one with the largest expected value, site A.